Hello everyone, it's February 14th. Alright, let's do it. Find the punishment number of an integer. We get a positive integer n. The sum of the squares of all integers I such that it's in between. The decimal representation of this can be partitioned into contiguous substrings such that the sum of the integer values of these substrings equals I. The punishment of n is defined as the sum of the squares of all the integers I such that 1 smaller than or equal to I smaller than n. The decimal representation of I times I can be partitioned into contiguous substrings such that the sum of the integer values of these substrings equal I. Let me read it again. The decimal representation of that I times I can be partitioned into contiguous substrings such that the sum of the integer values of them equal to I. So the punishment is n as the sum of the squares of all integer I such that I has to satisfy two requirements. First is it's between 1 and n, and the second is I squared. You can do some operation to make it equal. So okay, so n equal to 10. There is 3 integers in the range that satisfy. So 1 and is 1, 9, so a plus 1, 10, 10 plus 0, and you put these together with 182. 37, there's 4, 1, 9, 10. So basically it is just to find the total number of these things, right? You need to find what number whose I will have 1,000 to go through, and for each one you can produce its square. So the question is, given n, given a value x, right, and we have x squared, can we decide if how we can rearrange x squared such that the sum equals damn, how do you even find 36? Okay, 36 times 36 is equals to 1296. So basically we can say given a 1, and I can say I'll take the first by itself. Yeah, so essentially you will say the total sum plus 6. So basically you say can this make a 30? Right? If it can make a 30, then you can plus 6. And 96 is too big, it's not possible. Okay, so now the question is, can this make a 30? And for this to make a 30, I can say, can this make a 21? So I can say for 1, I can make 1. That's it. There's 2. I can say if 2 by itself, so this can make 3, right? This can make 3. So this position I can make 3. I can make 1, 2 together. I can make it 12. So at this point I can make 3 and 12. So I went 9. So 9. So we go back So I go back to this place, I can have this or this. So which means here I can make 12, or I can make 21. And then I can go here, and I can make 30, or I can go also, I can make 129. Now I go 6. So I go to here, I can add all these up, right? 18, 27, 36, boom, already hit it. Okay. Oh, that seems bad. So basically, we get a bunch of this. I start from here, right? We record. A vector of vector, and each position is going to be a vector. This is going to be a vector of 1. This is going to be, we put this in, and then we check every single one here. So we add this, and then we check this, and then we add this. Okay. So yeah, we do this for every single number. I wonder if I can save this somehow, but I think we can reuse it. But it's fine. We don't really have to use. We don't really have to reuse it. Okie dokie. Let's do this. So we're gonna say int, not int. So it's gonna be boolean. Is okay. Is okay. Some value x. So x-axis equal to x times x. All right, and then we'll turn this into a string. How do we turn it into a string? std2 string. Okay, so to string, actually, yeah, I do need it. And then we're just gonna go one by one, and then we have to set up a vector of vector what's that? Size. No, that should be fine. And then for int I, 0 is smaller than xstr size I plus plus, right? So for each one, we'll do is dp I dot pushback xstr I minus 0. Right, we always push this one first, and then for int j equal to I minus 1, j larger equal to 0, j plus plus. So I need to first find a base. Current. Okay, so now we are going to say, oh, shoot. That's fine. So basically 10 to this power, right? So how do I do power? 10 to the power. Power. Pow. Base exponent. So I can say current shall equal to current plus std pow base is 10. This is going to be I minus j. Right? Yeah, so this is the new current. Let me think. That's actually not right. I think it should be a -1. Current. Hold a second. So J is here, right? So current number shall be whatever this. Plus this. So as I move here, it's going to be... Okay, we'll actually do this at the end. So this is just going to be whatever this j will add to it. So say dpi. Oh my goodness. For int pre of dpj. Right? And we just say dpi dot pushback pre plus current. That's all you can get. Once we're done, current shall equal to current plus 10 to the this much power. I get a new current. And then J move on to the previous one. Okay, so by doing this, we get a dp for every single one. Yeah, we do this, and then oh wait, no, we have to go to the end. Alright, so we got this. We go through everything. We will put it, and now we add it. Now we go for the previous one. Now we have this, and then once we're done, we'll this times 10 to the more power, and then do that. Sounds about good. So once we're done with everything, we just say for int value of dp, the last one, right? Yeah, dot size -1. So if v is equal to x, then we'll return true. Otherwise, return false. Okay. All right. So now we can do this. We start with n, and then we go through everything, and then we'll add everybody together. So I say int res equal to 0 for I1 smaller equal to ni plus plus. If is okay, I res plus equal to I. And at the end, I will return less. Here's dp to decide whether a number x is equal to a substring sum, some substring sum of the decimal representation of its squared value. I don't know, this one looks pretty gnarly. Alright, so this won't be too big. This says most is 6. It's like 1,000, right? So this is 6. So 6, and this is also 6 and most. This can be pretty big, because each one, the first one can have 1, the second one can have 2, so this could be 1 plus x6 squared. So I think you can call it ON, right? Because you only grow based on this. Nah, we shouldn't call it ON, depending on the largest sum. So we can say can I say log m, okay, where m is the largest. Oh, it's just n, right? That's just n. You can call this as log n. Because you log it is just the number of the size, and then this is just the size and the size. Okay. Let's verify. This one looks good. Damn, I can actually do all the test cases. Actually, I don't think so. Minus. We're going to the left. Alright. I was not right. I'll have a 2 gun hole on this. That's fine. Let's just 10. Oh. An n-type solution. What are you talking about? Oh, got it wrong. It should be 50. Alright, so 1 and a 1 and a 1. Current is 1. So I push 1 back. So J is gonna be -1, so I don't do this. Get out, get out. And V is gonna be 1. It's true, so return true. Okay, so +1. Good. 2. 4. So the first is current is 4. Push it in. Nothing. Gets out. No. No. Gets out. False. Okay. 3. 3 should be false. Yep. Which is the next one? Should be 9 and 10. Okay, 9. 9 common is 81. Okay, so first is 8. Okay. DP, the first one basically is 8. So second 1. Okay. So basically I have 8. So push 9 inside. That's good. Nothing. So this will be basically 81. 11. Oh, I see the problem. I forgot to multiply. The J. Oh. Well, you do have to multiply, right? Yeah, but it's a two issues. Not only multiply, it has to times I. I forgot it's supposed to be squared. Wow. Yeah, these issues just popping up left and right. All right, 143. That is not what I had expected. How do you even get to 143? Alright, we have to. First of all, I want to cancel this and let's put. And then let's build it again. Mmm, 5. How is 5? Okay. 525. First we got 2. Nothing. Next I got 5. So I got 5 in. So that should give you 7. Yes, that gives you 7. Oh, because you have 5. Ah, you shouldn't push 5 in. My bad. Alright, I see. So, oh, this shouldn't be. I think it's just current, right? It's just the current value. And then, because it's ending at this, what we can do, ending at this. Okay, ending at this. So we just have the current. So the first one, it has to be treated specially, very specially. Current. And then you just start adding things. For example, if I is equal to 0, right? So the first one, so you don't have any of the other things. So you put this one here, and then you just call continue. Right? You just call continue. You push it in and continue. Alright, let's try this one. Oh, we missed 100. So there's something special about 100. Okay, let's see. Something special about 100. So 100, we have 1, and this we have 0. Right? So if we got this one, now we get 1. Or we get 10. This is, we get 1, a 10, or 100. So we should have this. What the hell? What was wrong? So 100 comes in, the first is 1, I equal to 0, yes, so I push this in, done, right? Next, current is 0. If current is 0, and then we go, the previous is 1, so 1 plus 0, so we push 1 in, that's fine. And then current equal to current is 0, and power is going to be 10. 10 times 1 is 10, so we got 10, right? We got 10 in the current. Then it gets out. I see what happened. Then it gets out, but I never really push it in, which means I believe I shall always push current at the end, because the last current is cover the entire thing. That one should always be considered, which means I don't deal with any of this. I just go through this, and then when the last one, right, this is the last come in, so like j equal to 0, right, and j equal to 0, it's fine. The previous j equal to 0, I do this, and then I add the last one to it, and then I cannot do anymore. There you go. We are throwing more cases. 1000, so 999. Actually no, 1000. We should just do 1000. Yep. Now I can submit. It's a little complicated, but not too bad. Run is pretty slow though. I don't know. Is there a trick to do this? Oh, I can see a trick. I can see a trick. For example, for example, I can set a constructor and I can set vector of, you know what, let's do this in a different solution. I'm not sure if it's gonna work, but it's worth a shot. So this is the constructor and then this is the okay, valid, right? And then this basically we're gonna run say for int I equal to 0, I equal to 1, I smaller equal to 1000, I plus plus. If is okay, I valid dot pushback I. Alright, so this is basically the constructor. So we handle all that. So when we do the punishment, we have n. We just go through them, or we can even binary search them. 1000, I think probably. Yeah. So we basically say we have n. So we say equal to 0. I smaller than valid dot size, right? And then we say if valid I is smaller or equal to n, so this will be valid I times valid I. And valid I is smaller or equal to n. So we do this. Right, let's try this. Try pre-computing all valid numbers, right, from 1 to 1000. Looks smart, but not sure the appetite of LeetCode. Is this even allowed? I guess it is. Doesn't allow that. That's fine. Doesn't allow 979 milliseconds. So yeah, it's not how it's called. Apparently the solution object is created on the fly. But this gives us one idea, which is how do we print? Nope. For int v of valid std cout v, this, probably have to do this. Okay, let's try build this. And how do we call it? There we go. It doesn't make any sense. Oh, why don't you choose the answer? So this is the thing. Oh, I forgot the damn. Do I already copy it? Yep, I already copied it. So that's kind of the third method, which I'm just gonna do it here. So we don't do this. And I also don't do this. Oh, we can do this. Std vector. Valid. Alright, pre-computed. Truly pre-computed. This shall be fast. Yep. That's how you do it. That is how you do it. 0 millisecond. I said I don't want to do it this way, but I guess at a certain point it's just too fun to let this pass. Come on. You have to admit this is a very fun way of doing it. Very, very fun. That's why you have this. Memoization. I think that's what we do, memoization. But I think much fewer lines than this. Maybe that's the right way to say. Start sum. We don't do start sum. Recursion of integers. I mean, I don't know. What do you think the runtime for this? I feel it's different from all the things that I saw. What I think is you have log n here. You run log n times. And for each one you do log n squared, right? And then this, the worst case is just 1 plus 2 plus 3 plus 4. So that's log n squared again. So it's just log n times log n times log n squared, and just time them together. So it is like log n squared. I don't know, but I don't want to get bogged down on this. Oh wow, 2023 I have so many different solutions. What did I do initially? ARU cache, and I gotta pre-compute. Yeah, it was crazy as well, pre-compute. So essentially I think settle down on something like this. And and I do a bisect. I didn't even cache. Yeah, I see what I was doing there. Same idea, but I don't do the recursion. I just do bottom up. Overall, the idea is the same. Okay, that will be it. I will see you guys tomorrow. Adios.